Alright, good morning guys. This is Mr. Milton here. Today we're going to talk about solving radical equations. We've talked about simplifying radicals and whether it's just radicals or radical expressions, adding, subtracting, multiplying, all that good stuff. Now we're going to solve for a variable with equations that have radicals involved. Okay, so at the end of this video you should be able to solve equations when we have radicals. Okay, and the process is straightforward. Here is what we'll try to do. These are the steps that we'll follow each time that we try to solve a radical equation. We will isolate the radical or get the square root by itself. Okay, and we'll do that using inverse operations, whether we have multiply or divide, add, subtract, things to get the radical on a side by itself. Once we do that, we will square both sides of the equation in order to get rid of the radical. And then once we get rid of the radicals, we'll solve the equation. And one extra thing, I know check the solution is always a part of our process, but we need to be especially sure to check the solutions in these cases because sometimes we'll get extraneous solutions or things that we mathematically reason to find to be the answer but don't actually work into the equation. Okay, so we'll see that. Alright, so let's go through a few examples and then we'll go through. Alright, so here are the examples. If you want to take a second to write those down, that'd be great. Alright, I'll focus on these first two. Alright, so we have first problem, we have radical x minus 3 equals 4. Okay, I want to show you these two problems at the same time for two reasons. Well, one, we'll do both of them. The other, though, is I want you to notice the difference between these two problems. The numbers are the same, but notice that in this problem the radical ends at x, and here the radical takes this whole expression. Okay, and so we'll handle those differently. Okay, for number one, our first step is to isolate the radical, get the radical by itself. Okay, on this first problem, minus 3 is on the side with radical x. Okay, so we need to get radical x by itself, and we'll do that by adding 3 to both sides. Okay, we do that, we have radical x equals 7. Okay, we could do that because the minus 3 was not inside the radical. If it were, we wouldn't be able to do it that way. But now notice we have radical x equals 7. The radical is by itself. To get rid of the radical, our inverse operation is squaring it. Taking the square root is the opposite of squaring it. Okay, so they cancel each other out. And so on our left side we're left with x, and on our right side we're left with 49. Okay. When we plug this back into our equation, we have radical 49 minus 3 equals 4. And that works out for us because radical 49 we know is 7. 7 minus 3 equals 4. Good. So x equals 49. Okay. Number 2, we have radical x minus 3 equals 4. We need to isolate the radical. For this problem, our radical is already isolated. There's nothing else on this side outside of the radical. Okay? And so, now we need to get rid of the radical by squaring it. When we square both sides here, we're left with, well, the square root of anything squared, or the square of anything square rooted, cancels this out. So we have x minus 3 equals 16. Solve for x, we'll add 3 to both sides, and so x equals 19. Plug that back in just to make sure that it actually works. And so when we do that, we have 19 minus 3 equals 4. 19 minus 3 is 16. Square root of 16 is 4. Is that true? Yeah, it works. So x equals 19. Okay, a few more problems here. I'll just move this out of the way. Alright. Here, for these next two problems, we have a square root on both sides. Okay, so in order to get rid of the square root, we will square it. Okay, notice that the radicals are already isolated. They're on the sides by themselves. There's nothing outside of it, so we don't have to add or subtract. And so now we need to get rid of the radical by squaring both sides. When we do that, they cancel out. It's pretty nice because now we just end up with an equation with variables on both sides, and we've been solving that since you came into this class. And now we just solve like regular. I'll subtract in from both sides. I'll add 2 to both sides. Okay. And that way I'll leave myself with 2n equals 8. 2n equals 8. N will equal 4. And I'll plug it in just to make sure I get good numbers here. So 12 minus 2 equals radical 4 plus 6. And it has to work out because 12 minus 2 is 10, 4 plus 6 is 10, square root of 10 equals the square root of 10. Makes sense. Alright. Number 4, very similar problem. If you think you know how to do it, do it. Check my answers. Come back in like 25 seconds, 30 seconds probably. Okay. Square root on both sides. Squared it. Cancels that out. I'm left with 3t plus 4 equals 5t minus 6. And now I solve for t. Subtract 3t from both sides. Add 6 to both sides. So I'm left with 10 equals 2t. Alright, I'm going to solve for t now. Divide both sides by 2. And t will equal 5. And now I just plug this back in. Yeah, 15 plus 4. We have 25 minus 6. 15 plus 4 is 19. 25 minus 6 is 19. So I'm saying the square root of 19 equals the square root of 19. Yes, it does. Okay. So again, solution works out. Alright, last problem. We have the square root of 2x plus 6 equals 4. Notice our square root stops here. The plus 6 is not underneath our radical. Okay, and so now to solve, what will we do? Well, we'll subtract 6 from both sides. And so we're left with radical 2x equals negative 2. Okay, so now we have the square root of 2x equals negative 2. We need to, now that we've isolated the radical, we need to get rid of the radical by squaring both sides. Square both sides. That leaves us with 2x equals 4. Divide by 2. X equals 2. Okay, and so now we'll plug it in to make sure that it works. So we have radical 2 times 2 plus 6 equals 4. So we have radical 4, which is 2, plus 6 equals 4. No, it doesn't work. Okay, that is not a solution. Okay, and that's the only solution we could find with our math, and so this one has no solution. I want to show you why it doesn't work. Okay, as we look up here, we have square root of 2x equals negative 2. Okay, here's the issue. A square root will not be able to equal a negative number. Okay, and anytime that happens, we can almost know for sure that it's going to be no solution. Okay, but I want to make sure that you guys go through and solve or plug in and check your work, because we will have extraneous solutions or numbers that come out when we solve but aren't actually true. Okay, so here's the process. Isolate the radical. Square both sides to get rid of the radical. Solve the equation and then check your solutions. Remember, you have to check your solutions for problems just like this. Okay. Oops, I'm too low. You have to check your solutions for problems just like this. Otherwise, when you solve it, you will end up getting a number that doesn't actually fit. Okay, so again, just because I was off the camera, we subtracted 6 from both sides. We squared both sides. Okay, we ended up with 2x equals 4. We found that x was 2. But once we plugged it in to our equation, we got 2, or radical 4, plus 6 equals 4. Radical 4 is 2. 2 plus 6 is actually 8. It didn't work out for us. Okay, and we would need this radical to come out to be negative 2 in order to solve this problem. Okay, so there's no way that that could happen. So there's no solution for that problem. Okay. All right, we'll look at some more problems tomorrow. See ya.